Hello and welcome to Code and Supply's first online lightning talk tonight. We have done a few meetups since the start of the pandemic online, but this is the first one that we have done that is distinctly nothing but lightning talks. So we're stoked to have these 6 folks do these talks over the course of the next approximately hour. It could be a little bit less than an hour. It could be around an hour. They've been told we're shooting for 5 to 10 minutes, probably closer to 5, but I won't cut anybody off until it gets to 10. I would tell you a little bit more about the people who are speaking and the and their talk topics. Unfortunately, Meetup, that is the repository of that, is currently down. So we're going to have each speaker tell you what they're talking about, or just go right to it and you can figure it out. So our first person up tonight is Jeanne.
Hi, everybody.
Go ahead.
And happy non-binary person day today. In honor of that, I would like to greet you. Good day, ladies and gentlethems. Let's see. Let's start sharing my screen here. I practiced this beforehand. We're ready.
Take it away, Jeanne.
All right. So this lightning talk is about how to get rid of some changes that you've already made when you're using Git. This is a topic that I've answered questions about a couple of times in chat, and that made me say, hey, maybe it'd be a good thing to talk about in a lightning talk. So just to set a base here, what we're going to talk about is useful if you're using Git as a version control system to keep track of, save points in your workflow as you go. Those save points are called commits. And there are reasons you might want to get rid of one, and you have options for how you're going to do it. I'm going to show you the 2 most common ones and how to choose between them, and also how to do each of them. So here are some examples of commits that you might want to get rid of. There are all kinds of reasons. Maybe you either removed some code or added some code, and now you need to undo that change. So sort of like a Control Z. Maybe you committed some sensitive information that shouldn't be in your repository because other people can see that information. Maybe there's a password that you committed by accident, or an API key, or a list of users' email addresses that you were using for testing. Or maybe you just totally made a mistake and that commit shouldn't exist anymore. This happens to me most frequently when the string of commits looks like, gosh darn it, cloud system, will you please just work right this time? One more try. Try again with a semicolon. How about this? Does this work? So there are all sorts of reasons you might want to get rid of a commit. Here you are in the situation where you've got one that you don't want. How do you get rid of it? Here's the specific setup that I set up for the purpose of this, and I'll show you 2 ways to solve it. In this screenshot of my Git log, my history in this repository that I'm working in, you'll see that I've got some four commits here. I did some work a couple of days ago, and then today I added in my API secret, and then I did some more good work after that, and what? I've put a secret into my repository. I've got to get rid of that somehow. If I haven't done any of that good work afterwards, I could just reset all the way back to that setup config file commit. But I do want to keep that other good work that I did. It's just that I want to get rid of this one commit from the middle, that add API secret. I want to get rid of that. So here are the 2 possible solutions, revert and remove. They have 2 different results for your Git history. And on the right there, you see what the result of performing the solutions is. When you revert a commit by committing its opposite, the original commit is still in your history, but you also have an additional commit that undoes it. So you end up with 5 commits instead of 4, but the changes that original commit made are undone. On the other hand, when you remove a commit by rewriting your Git history, that commit no longer exists. Instead of 4 commits, we now have 3. It's like you never made that original commit at all. Let's look at each method individually to understand how to do them and why you would want to do each one. To run a revert, you use the command you see here at the top, git revert, and then you provide it a pointer to the commit that you want to revert. In this example, the way I've identified that commit is by its hash. So you see, if you look down at that log below, the git hash associated with add API secret is 32b262, and that's what I provided to git revert. And as you can see, when I ran this command, it added a new commit that was after all the other ones in time. So what is this new commit? Basically, for every line that the original commit changed, the new commit does the same thing, only it does it backwards. So for every line that the original commit added, the new commit removes. For every line that the original commit removed, the new commit adds. For every line that the old commit changed, the new commit does the reverse change of it. Something important about this commit is that at the end of making it, when you're done with that, it applies cleanly on top of the history you have so far. If there had been any problems with making it, any conflicts, like for example, if add API secret changed a line and then some good work also changed that line, you had to figure out which version was the right version, you have to resolve that conflict as you're making the revert commit. So that revert commit in the end contains the correct fix that you have decided on for that conflict. What this means, this applying cleanly on top of everything, is that at the end, if anyone else has a copy of this repository so far, and you provide them with the new commit, it just, like for example, if you're following your normal push new code process, it just applies cleanly like a normal change on top of their history also. They just follow their normal get new changes process. This is important, and we'll come back to this as we look at the other method of getting rid of some code changes, which is removing. So git revert adds a new opposite commit. So to remove a commit, which is the other method, you have to rewrite history. This slide shows what happens when you do that using the git rebase command. In this example, there are other ways to do it. This is one example of a way to do it. Here we did a interactive rebase. You see that interactive flag, and it starts from a certain commit and allows you to change any commit after that. So I gave it a pointer to our original commit in this repository and said, let me change all the other ones after that. So when you run an interactive rebase session, Git pulls up this file, and that's this middle thing that says pick, 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 showing you all the commits, one per line, since the starting point that you chose. If you just save this file and quit it without making any changes, Git applies all those commits, and you're back to where you were before. But if instead you edit these lines, you can make changes in the middle of your Git history as they're being applied. You could add new commits. You could reword or make changes to the code in existing commits, or you could remove a commit. So to remove the unwanted commit, what we did was remove that middle line, that pick 32b, just get rid of it, save the file, and quit out of it. So each of the remaining commits are going to be applied, and that results in the Git history that you see with only 3 commits. The add API secret commit and the changes it made just don't exist anymore. Your history is clean, it's beautiful. If there was a conflict, like if some good work changed a line that add API secret added, you'll have to resolve it as you do the rebase, same as if you were doing the revert in the last method. But the big difference between these two is, what if this code exists somewhere else? Like if you're using GitHub or GitLab to share it with team members. When you try to push your changes up to that shared instance, Git is going to complain. It'll say, the remote repository has a different history than this one. Are you really sure that you want to do that? You're going to have to do a force push, which will overwrite what was in the remote repository with what's in your current version. And that's certainly possible. It's part of what Git allows, but it can be bad and dangerous. If a coworker tries to pull from that shared remote repository after you've done a force push, they'll suddenly find that there's a different history. Any work that they were doing might not apply cleanly on top of it, and they have to do some Git gymnastics to get everything back in place. Now multiply that by however many people potentially have a copy of this code. It's not always easy for them to tell exactly what's going on, and you have to communicate a lot about what's happening with this. Worse than that, though, if a team member had pushed some of their own good work up to the repository while you were making your removal on your computer, when you do a forced push, your history replaces what's up on the remote version, which means their work disappears if you haven't pulled it down yet. So this method that changes history, changing shared history, is complicated and potentially dangerous. If you have pushed the history at all, then reverting and not removing is almost always certain to be a better answer. So the difference between the two commit removal methods is what they do to the Git repository's history. I'm going to quickly tell you about some situations that might arise and ask you to think about in your brain and maybe indicate with some pointing left or right, towards the side of the screen with revert for revert and towards the side of the screen with remove, which you would choose for each one. All right, situation 1. You have a string of commits locally. Like make the continuous integration work. Try 2. Drat, that didn't work either. Now, how about now? Okay, you have this string of commits that you haven't pushed to the shared location yet, and you want to get rid of the false tries, only leaving the good code. Would you choose to revert or to remove? I have no clue how to get your responses, so I'll just give you a moment to think about it and tell you what I would do in this situation is probably remove them. There's no shared history. I'm totally free to clean up my own personal history that I haven't pushed anywhere. What if you're in the same situation, but you have pushed to the shared location and you're not sure if anyone else has downloaded it yet? Well, in that case, it's probably not worth cleaning it up. Maybe you can use your remote location's squash functionality on this pull request, other topic, to sort of clean those up a little bit. But maybe it's just fine to have this mess in your history in favor of having a good experience for anyone sharing it with you. Okay, what about if a line of your code fetches data from an API and you've got a commit that includes the API key and you had to pay for that API key? You're going to have to pay more if anybody else uses it and goes over your limit. You have pushed this repository up to a public GitHub repository. In this case, would you use revert or remove? So me, I would probably go get a new version of that API key. But if my option were revert or remove, I would definitely go with remove in this case, because I need to get rid of that information out of my history, not just out of the current version of my code. All right, cool. So I hope that you are walking away from this lightning talk able to make some good decisions about how to get rid of that commit. That's it. I'm Jeanne Lang. I teach at Academy Pittsburgh, Pittsburgh's first coding bootcamp. I'm happy to hear questions and comments via email or on Slack or in person when we're not in a pandemic. Thank you for your attention.
All right, great. Thank you so very much, Jeanne. Next up, we will have Benji. Benji's going to talk about the Jamstack.
Thanks very much, Colin. Give me just one moment here.
While we are waiting for him to rejoin, I'll do a quick little announcement where I will talk about Heartifacts. Heartifacts is our mental health, community building, and career management conference that is coming up in August. Go check it out at heartifacts.codeandsupply.co. Tickets are available now. It's streaming online. The interactive sessions are what you pay for, starting at $50, going up to $75. And you can participate in our interactive online sessions where we will be doing live QA and breakout rooms and some fun activities.
Okay,
Back.
I've changed over to Chrome, and Chrome is being so gentle to me.
Guess who's back? Benji's back.
Again. Okay. Is this the right screen?
Yes.
Okay.
You're good to go.
That's my name. Cool. Let's just check, does it change? Yes, it does. Very good. Okay. I'm going to assume everybody's ready. Thanks so much for allowing me the opportunity to evangelize a little bit about one of my favorite topics. My name is Benji. Tell you a little bit about me. I'm 32 years old, and I am a front-end developer at Top Hat, which is a local marketing firm here in Pittsburgh. We're currently in Millvale. And I use WordPress pretty much every day, but I also use many different frameworks when I'm doing different things. And I'm here to talk to you about why you should probably be using Jamstack in a couple situations. And one of them, the biggest one, is that you probably need a personal website. It doesn't really matter what your job title is. If you're a web developer, software engineer, if you have roles that are related, you're here because you are interested in tech. And tech has a lot of web stuff. And so you want to show that you're capable of doing complex things and you're using the cutting edge tools. And so talking about web stuff, I think maybe very, very simple terms. There are two kinds of websites, and some websites are do websites. So do websites will do a lot of fun things, dynamic things. Usually they change quite a lot. So maybe there's some user-specific views, and every single person that comes to your website sees a different thing. Maybe you've got a store that has an inventory that's changing all the time. Or maybe you have lots of data. Maybe you're doing some really crazy math. I know Code and Supply is full of a lot of really exciting technology. And so sometimes you need some really complex things that you need to show on your website. And if you're doing really complex things, then I call it a do website. Why not? But a lot of the websites, I'm going to say a majority of the websites on the internet are show websites. And they're very different. Show websites display something. They're going to talk about something, show you what it is. They define that thing. They attract viewers. And then what they want to do is engage the viewers and then convert them into evangelists for that thing. So in this poster's case, Legos. But your website's going to do that too, because your website is advertising you. So it doesn't need to be terribly dynamic. It can have some dynamic parts, but your website is advertising and showing people about you. It's going to be the same for most of the people that visit. And the cool thing about show websites is that they're changing pretty quickly. You've probably seen a lot of older versions of show websites, and maybe you use them. WordPress. WordPress is a pretty common example, but there's also Drupal, or maybe you're doing some interesting things and you're showing some of your technological skills. So you're using Django or Rails, or you've got some WYSIWYG. There are some options there, something like Wix. Or maybe it's 1990 and you're using something else. But these days, with these show websites, it's pretty common to see something that's a little bit more like 11T, Gatsby, Next, Hugo, anything really. But a lot of that is JavaScript based. And the reason that you're going to use JavaScript is, well, if you're already doing front-end views of websites and you're already doing something that your browser is able to support, then just why not keep using that tool regardless? So why are these websites changing? I think things are a lot faster and easier today than they were about 10 years ago. So we have this cool thing that's been developed called the Shadow DOM. And the Shadow DOM does some cool stuff where you can change pieces of a page without reloading the whole page. So you can pull in new information without having to call a full refresh of all the information that's currently there. And also internet download speeds are fast, so you can do some cool things with big pictures and videos and fun stuff. And then there are APIs where you can pull in new information without reloading the page. And these APIs are getting more sophisticated. They're using a lot of JSON, and they're very, very easy to use. And then finally, all the browsers are getting a lot of good support now. So the tools that we use on one browser will be the same for all of them. It's it's getting much, much easier to work on. And so now the people want their websites very, very quickly. It took that slide, now if it's working properly, it took that slide about 3.2 seconds to come in. And 3.2 seconds is about the maximum amount of time that you want to see with your website. In this graph, you can see that the blue line gets high quite fast, and that blue line is called bounce rate. That's when a person views your website one time, and then one page, and then leaves. And so you can see after about 3 or 4 seconds, that bounce rate is almost like 40% of your users that are going away. So low bounce rate is really good. And one of the ways that you're going to get that low bounce rate is doing as little work as possible on your page before you serve it to your users. And so that's where you're going to build static markup of your pages. So here's an example of a really cool website that you should probably go look at sometime. This is Cassie Evans' website, and she's got a whole bunch of talks. She's got some really cool talks you should listen to sometime. And this is not how she made her website, but this is one way that is pretty common to do it if you have one of those old style show websites. You can use some PHP, and you can store the talks in a database, and then you can go and you can get that, and you can iterate through every talk and grab the information, and you can output it to the page with PHP. But that means that every time somebody views this, if it's not cached, every time somebody views this, the PHP is going to go through and render that page, and then it's going to send it to the user. That's taking time. Your server doesn't need to do that. And so today, with a lot of these new static site generators, there's an option to build your page first and to make that markup exist already on the page. So that way, you've got a copy of the HTML that you're going to send to the user, and the end result is that your page is really a lot faster. So I guess there's a question, are there any limits to this method? And I think we answered that before. There are some websites that need to do things, but most of the time I'm finding there's not really a lot of limitations. And I know that we are some pretty competent developers, and we do some pretty cool stuff. And with this, you can find solutions. So even if you're making a shop, you can still use that API and ingest the data from the API and make it available. Is it safe? I would say it's safer than some other options. You've still got data somewhere. You've still got a repo somewhere. And well, I guess with Jeanne's talk, we can make this a little bit easier and say that we have ways to change that to make sure that it's safe. But you're a human being. But otherwise, there's no database. So if your website, if somebody gets access to your website, it's not going to change. It's static. So it's pretty safe. So I think that's where this method is becoming a lot more popular, a lot faster, makes it a lot better, keeps more users interested in you, and it makes you more likely to be a profitable engineer. So I'm really excited to see what everybody takes away from this, and I'd love to see some of the work that you're doing in the future. So use Jamstack.
All right. Excellent. Thank you very much, Benji.
Thank you. I'm trying to stop sharing here. There we go.
Benji, I'm applauding. I don't know if you can tell, but I want you to know that I appreciate you.
Thank you.
Cool. Arnie, have you joined in the meantime? Arnie, have you joined in the meantime? All right, now. All right, let's move on to Remy.
Hi there. Hi, I'm Remy. Let me get my screen out. I think I'm sharing, yes? All right, fantastic. So I want to talk a little bit about is a short project that I did recently on my own. And I call it Visual Phaser because that just sounds cool as heck. And I want to talk about it because it's a really lovely introduction to the practice of what's often called creative coding. I happen to be a developer at a company called Ion Tank. We're over on Penn Avenue in Garfield area. And we make stuff like that picture you see. That is a 45-foot tall chandelier that is in a building in Pittsburgh that I can't tell you which yet because they haven't actually opened to the public. But it was a really cool project. And all of that glowing LED light that you see in there is driven by an app that I and a couple other developers built that is written in Unity, and it's interactive, and you can play, and you do stuff on the screen, and stuff happens on the chandelier, and it's very exciting, and it's very fun. And it was a huge, very effort-intensive project that took better part of a year for the whole shop. There's a lot of parts, as you can kind of see from the picture. There's a lot of complexity to the software. It's one of those big projects that is really satisfying to work on, but required a lot of time and a lot of energy. And there's a certain part of me that's like, but I'm lazy. I didn't become a programmer because I like to do work. So as satisfying as that was, I love building these complicated things, but I really love to build a complicated thing when it's but here's a simple animation. Well, it looks complex. Complex looking animation that is actually built out of some very simple software. And I want to take a couple minutes to talk about that basic technique. And because I'm on the bold side, I'm going to kind of do this in a little bit of a live coding fashion. But what you see here is a very simplified version of the software that generated that little video I just showed you. And what I want you to note here in this software is it is just dots moving in circles. I built this in processing. Processing is a popular tool for this kind of creative coding work. It's popular because it's simple and easy to use. It's a Java-based language. But it has a lot of built-in methods to make it easy to draw things to the screen. So that's why we're using it. Tool doesn't really matter. What I really want to get to is this idea of a technique, because I love this technique. I have circles, dots moving in circles. I'm going to turn off those little circles just so that we can agree that, hey, we can agree that, hey, same animation. It's going to be dots moving in circles. Same thing. I just turned the circles off. But what I'm going to get at is if we look kind of how we position things. If you remember your high school trigonometry, you can define the XY points on a circle by the sine and the cosine, right? The X is the sine times the radius. The y is the cosine times the radius. Very, very simple arithmetic. And one of the things that we do, we're driving it by time, right? Because it's an animation, and you don't need to worry about where time is calculated. It doesn't matter for this. I have these little dots moving in a circle based on time and based on something I'm calling phase. And this is why it's called visual phasor. I have a little handy function here, and all of this code is linked from the slides, and I'll put the slides in the chat after this. But I can, for each one of these dots, I'm going to have circles moving at the same speed, dots moving in circles at the same speed, but what I'm going to do is I'm going to change these. I'm going to offset where they start in their circle a little bit. And when I do that, here I'm doing it driven by a noise function, right? It's ugly, it doesn't really make a lot of sense, right? But this is the same animation with all of the dots starting in a slightly different spot. And since we're already using some of our old high school trigonometry, one of the really fun things we can do is start playing with functions like that sine function, right? All of a sudden, I can get these nice little wave-like patterns going. I'm going to actually increase the number of dots. I'm going to shrink everything down real quick, just because it looks cool, right? We're going to get this nice little wave-like pattern going. And I know, again, it's a little probably hard to see in the screen share. Dots moving in circles. And I can get really fancy. I could do a whole 45-minute talk about how much I love the smooth step function. Google it. It is a sigmoid function, makes a little S-shaped curve. But I can do some really nutsy sorts of things with that kind of function. So here we have this lovely little pattern. And you can start to see here, I haven't written a lot of code. This is one of the things that I really want to highlight with this technique. It's not a lot of code. The bulk of the code is this draw point function. And it's this phase function where all I have to do is say, hey, offset the circle, move the dot in the circle just a little bit. And I can get all sorts of really fun patterns and generate super complex looking things by just playing with that phase function. I could spend a whole bunch of time doing more experiments with this, but what I really want to focus on is the simple idea, dots moving in circles, starting in slightly different places. I can write a function that determines what those places are, and I can make this function as big and complicated as I want. I can do as many weird things as I like. I can play around with these little constants, how fast it goes, how much space there is between the dots, how big a radius the circle is. Just for fun, what happens if the radius is really big? A little more action-packed, right? I can play with this. I can experiment with this. I can iterate. And it took about 15, 20 minutes to actually put this code together. And then from there, it's a toy that I can play with. And I can do all sorts of fun little things. I love this sort of really complex output from really simple code and simple behaviors. And one of the things for the whole art kind of creative coding, for generating images, generating videos, generating animations, you don't have to put a lot of thought into things. You don't have to put a lot of work and time and effort into things. What you can do is you can just go and draw a little picture, draw a circle, and then start mucking with it and see what happens. So thank you. That was just kind of my one little thing I wanted to share. It's a fun little tool. I need to reach my screen. I'm going to just paste my slide deck in the chat for reference. That code is up on GitHub. I encourage you to just kind of take a look and play with it. It's a really fun little toy. You can draw some really cool pictures. I also have links in my Twitter, or in the slides, I have links on my Twitter that will let you, oh, I posted the edit link, didn't I? That's right. I'll put the correct chat link in the chat. But thank you very much, and yeah, enjoy the rest of the talks.
Excellent. Thank you very much, Remy. Really appreciate it. Very interesting work. Sarah's up next, and while she's getting ready, I want to tell you about the new Code and Supply job board. It's actually a pretty old feature of our website. It's been around for about 2 years now, but we made some very serious modifications to it recently and made it syndicate out. So whenever new jobs are posted on our job board, they go to Twitter, they go to Slack, and they get automatically included in our monthly newsletter. It's pretty cheap to post right now. We're doing I would call it an introductory rate, but mostly the code doesn't exist in our website for us to charge anything more than this right now. So we're doing it really cheap. We've been getting some decent traffic. Those of you who are a member of our Slack and see the information going into the job board channel or the freelance channel, you know that you've seen it, and you know that you've probably taken a look at it. All right, enough messages from our sponsors. Sarah, are you ready?
I think I'm ready. Hopefully you can all hear me decently.
All right. Excellent.
Okay, cool.
Go ahead.
All right, let's do the screen share. And I see that I'm sharing a screen. Does everybody else see that I'm sharing a screen?
Looks beautiful.
Thank you. Thank you. It looks beautiful in its grayness. So my name is Sarah Withee. I like to call myself a polyglot software engineer just because I work in all sorts of different languages. I work in all different things. And to go with that kind of randomness, I would like to talk today about how a pinball machine works. So back at Abstractions, back in August of last year, we did this sort of cool pinball theme. So this is our poster for the event. And if you look really closely, you can see all sorts of like cool techie nerd things that are going on in there. But at the event, we got the cool opportunity to have 6 arcade games and 6 pinball machines. And these are all very retro pinball machines. They were from the 60s and the games were all from the 80s. So this is my adorable conference organizing selfie there. But one of the cool things that happened was the organization that brought them pretty much is just kind of like, we need somebody to manage this. Oh, Sarah, you're here. Would you like to just have the keys? Here's kind of how to quickly repair things if things go wrong. And I'm like, cool. All right. And one of the machines was this mini Zag machine from 1968. Was one of the ones that occasionally stopped working for some reason or another during the event. But you can tell it's really old because there's not that much on it. It's very hand-drawn. All the doodads and gizmos are all pretty old on there. But to kind of look, I tried attempting to do a very playthrough of it. I don't think I shared sound, but it's kind of doing like old, like telephone sounds whenever it hits things. So it sounds like a, an old school rotary phone almost. I was terrible at holding a camera in one hand and playing the game in the other hand, but I kind of want just to talk through some of the coolness of it. So obviously the initial thing that happens with most pinball machines is you put in a quarter and then it starts the game. But inside what happens is you have, hopefully you can kind of, I don't think we can see my mouse in here, but so it goes down this slot that the red arrow is pointing at, and then it goes into what's called the coin mech. And the coin mech is basically sort of like a weighted scale. So it determines the weight of a quarter or whatever coin. If it's correct, it falls down one chute. And if it's incorrect, it falls down the other chute. If it doesn't match up, the chute that's not correct kind of gets returned to you. If it is correct, it lands in that box over on the right that the other arrow is pointing at. Here's sort of, my keyboard is messing up on me. There we go. Yeah. So the right arrow on the bottom is that sort of coin return back to you. And then the one on the left has a little switch. So whenever the coin hits the switch, it knows it's gotten the correct one and tells it like, hey, the game can start. But also inside this cabinet is this lever over on the right. And this lever is actually how you open up the machine. So if you were to slide that over, the glass on top can now slide all the way off, and including this little plate on the bottom. So the plate comes off, the glass slides off. So this is what it looks like. You can't really tell. But from there, you can lift up the entire base of it and kind of prop it up with what looks like a prop rod on a car, basically. But so you get this cool bottom of the playing field, and there's all sorts of doodads and gizmos and electronics on this. And then inside the box, you can see all the old things. Obviously, newer pinball machines have a lot more better electronics, but I thought the old ones were really kind of cool. So we're going to dive into some of these real quick. So bumpers, which are kind of the classic pinball machine thing we all think of, you can kind of see on the top and bottom of them are metal parts. And you probably never thought that a pinball machine ball is steel. It's metal because it conducts electricity. So there's electric current that runs through one of the two sides. And then when the ball touches it, it completes that connection and it knows you hit it. So one thing it can do is keep score every time you hit it. You get a few more points. The other thing is If you look at the underside of a bumper, there's what's called a solenoid under there. And that's the little thing on the left that's like the brown coil, the brown tube. And if you ever made electromagnet in school where you like wrapped a wire around a nail and it became a magnet, it's kind of the same thing. So there's a coil inside that brown thing. When you apply electricity to it, it shoots this metal thing out. And that's actually what happens here is that bottom ring will actually bump up when it gets electrical signal, which shoots the ball the other direction. So that's why they're bumpers. They literally fling the ball out the other direction when it gets a current. So that's kind of what happens here. Underneath, you have these rails. So it's kind of the same idea that when a ball hits in that middle part, the outer two metal parts will fling the ball back out. So it works almost exactly the same way. The solenoid for that is almost exactly the same. So that's how those work. Flippers are kind of also a classic pinball thing. These also are kind of interesting in that they slide inside and outside. They're activated whenever you push the button, and they can be actually enabled and disabled. Underneath, they're almost also solenoids. So the flipper, whenever they get an electric contact, they turn a motor that kind of flips them up, or a solenoid that kind of flings them the other direction. In this case, you can kind of see it's attached to a little ring. So whenever the solenoid activates, it flings the flipper up. There are different parts where you can run over a variety of switches or sensors with the ball. Those are also just simple electrical contacts. The one on the right is actually a sunken in thing. So whenever it gets into there, it activates the switch and then you can fling that ball out. Kind of same thing. There's two little metal parts. Whenever the ball hits it, the two metal parts connect, creating that electric current. So it knows it's hit those things. So lots of a lot of them are like a lot of the simple kind of same repeat things. If you've ever picked up a pinball machine or shook it a little too violently, you notice you got like a tilt warning or possibly like your whole game stopped. There's sensors inside that do that too. So the bottom one is a tilt sensor. You can kind of see it's like a weighted thing that's hanging there. Whenever you shake the machine, it kind of wiggles that weight around. And if you shake it too hard, it'll actually touch the side. And you can kind of see there's wires touching the top and wires touching the bottom. If it makes the electrical contact, you hit it too hard, it knows it made that. And you can actually adjust the height of the sensor. So it knows how violently you can kind of hit the machine before it activates. You can also stick a ball in the top part. So if people try to lift the machine, it will hit at a certain rate until it somebody messed with it. For the old machines, they're scoring wheels. So it's literally like entire wheels inside with numbers that are painted all the way around the edges. Those correspond to the inside of the box, or these wheels. And whenever there's things like you hit a bumper or whatever, these wheels get a little bit of a motor that turns them. And then the little, kind of hard to describe, but the little metal pieces you see on top are actually what trigger the wheel to turn on the top part. So it actually knows it keeps score. When it gets to a certain part on the wheels, certain gears will rotate the next one over. So all it really does is apply a current to one wheel and just all the wheels turn. And one of the cool things, if you were at Abstractions and you noticed when you started a game, there's a whole bunch of like clicking and grinding in the beginning. And that was it actually resetting all of these wheels back to 0. So it's kind of cool to actually watch this in person. So this is the inside of the machine again. Hopefully you found this somewhat interesting. And the reason I wanted to talk about this was the more I looked at the pinball machines, the more I realized they were very pretty on top, but they were really ugly inside. And I thought that was a lot like our software projects. Anyway, so my name is Sarah Withee, Geeky Girl Sarah. If you kind of want to look at these again or look at any of the pictures up close, geekygirlsarah.com/pinball will take you to all my slides. And thank you very much for watching.
Excellent. Thank you very much, Sarah. It was awesome. The layout of pinball machines is pretty wild.
Yeah, newer ones are also, you would think with modern technology, they would simplify. They're not. They're just as ugly. They just have more modern circuitry inside.
Cool. All right. So just a quick note on membership before Aton is up. We'd love to see more people join Code and Supply as paid members. Plans start at $10 a month, and your monthly subscription will help us last through the pandemic. One of the things that I've said in our newsletter for the past few months is that with the pandemic being a thing, people aren't really able to come into our co-working space, but we still have to pay our co-working space bills. We still have other bills to pay too. So our revenues are pretty far down. So we're relying pretty heavily on the community to try to come in and give us some support, basically spread the load out over maybe 50 to 100 people instead of the approximately 10 to 15 people who are no longer able to be in the workspace. So we would love to have your support. Check out codeandsupply.co/join. All right, Aton, are you there?
I am.
Excellent. Hello.
Hello. Let me share my screen. Let's see if this works. Can everyone still see it?
Yep, you're good to go.
All right. So my presentation is called How We Made Our Daily Stand-Ups Useful and Why It Didn't Matter. So this all started about a year ago when I realized my team's stand-ups sucked. They were taking way too long. We had a team of 8 people, range between 8 to 10 people, and stand-ups were on average 30 minutes. So pretty long. So I decided to roll up my sleeves and say, let's fix this. So first step in fixing a problem is identifying the nature of the problem, right? So after sort of spending some time looking at what we were dealing with, what I realized is we had 3 real problems. We had horrible signal-to-noise ratio. Parking lots involved too many unneeded people. And the tools we were using for running our stand-ups were just making our jobs more difficult. It was not helping us in a lot of ways. So what I did was set about trying and solve these problems. So for the signal-to-noise ratio, after looking at for a little while, what I realized was the problem was we had no real standard for what people should be putting in their updates on a daily basis. So people would just sort of drone on and talk about a lot of different things, and there'd be a lot of side conversations, and it wasn't very useful. So people would tune out, and it was just, someone gives their update, takes too long, next person, no one's really talking to each other. So what we did was, as a team, decided, okay, from now on, here's the standard. You only give, during your update, concrete steps you are going to take over the next 24 hours. That had a lot of very good effects. One, it drastically shortened people's updates because now they could focus on specific things and just talk about those. And 2, people were able to give real comments and feedback to other team members. With concrete steps, it was much easier to say, hey, you're either doing it right or you're doing it wrong, or here's some advice, or things along those lines. So that really helped. The next problem was our parking lots, and that was a similar problem of people would show up to these parking lots and wouldn't really be involved. So they would just sort of sit there and listen. And it's kind of a waste of time. In many cases, it turned out to be a waste of time for those people. Or people would show up and lengthen the parking lot because they weren't involved and they didn't really understand what's going on. So in that case, what we just said was made it really easy. As a team, we decided that at the end of the stand-up, we'd have the list of parking lots. Someone would have to give a few sentence summary of what the parking lot was about, and then everyone voted for the parking lots they wanted to attend. If you didn't have half the people in the stand-up voting for a parking lot, it just didn't happen, and instead happened offline. So in Slack or something like that. And that also drastically improved the timing of our stand-ups. And then the final problem, which was our tools. So we had some needs, which our tool, we are using ZenHub for doing task tracking and management. And what we found was we needed certain things. We needed the ability to display a summary of what needs to be done for each task for the day. So in one place, we wanted to see everyone's summary of the concrete tasks they were going to do for that day. We also needed the ability to group the tasks in an ad hoc manner. So as part of our sprint planning, our sprints last 2 weeks, we set goals. And those goals are higher level things that usually tend to be things like, deliver this product, or deploy this thing, or something where you can break it down to a bunch of subtasks. And we wanted to group those subtasks along those higher level sprint goals. And finally, we wanted the ability to allow for ad hoc changing of our stand-up process. So what we discovered was, in addition to just giving our updates, we needed to actually be reviewing and talking about some other things on a regular basis. And in a second, I'll show you what some of those things were. But basically, we need something that allowed us to track information in an ad hoc way. So the solution here was using Murally. So Murally is an online whiteboard. I think there's a better name for it, but that's effectively what we used it for. And what you can see here is a template we used for our daily stand-up. So the top part here is where we would do our updates, right? So those purple stickies there represent the different sprint goals. So what people would do is create their little yellow stickies and put them next to the appropriate goal to talk about what their plans were for the next 24 hours for the task they were working on. And then below this dotted line is the stuff I was talking about earlier, where we discovered, there's a lot of stuff we kind of need to keep track of and make sure we're paying attention to on a daily basis. So, for example, unplanned work. If unplanned work showed up, we wanted to be aware of how much unplanned work we were dealing with on a regular basis, right? So at a quick glance, we should be able to see, over the past week, all of our work has been unplanned. That's bad, right? We also have things down here like the vulnerability daily check. So we have a daily scan that does vulnerability checks on our code. We need to actually check the results of those scans and see if there's anything for us to do. If there is, get tasks on our board to deal with that stuff. And these checks basically come and go, right? We added the vulnerability daily check a few months ago. And the on-call check was also added recently, where the on-call person gives a daily update of what's going on. But there have been other checks that we've needed and then didn't need, so we removed them. And so that's sort of the ad hoc part that we really needed to track, to be able to deal, easily change around as needed. And then here we have the parking lots, where I mentioned the voting, right? So the parking lot stickies go down here, and then everyone uses dot voting here. These dots have the names of all the people on our team, and you just vote, on the things you want to be part of and go through the process that I described. So the end of, I want to say 2-ish months, 2 or 3 months, we had a drastically better stand-up. It was lasting on average somewhere between 7 to 8 minutes. People were getting more information out of it. And more importantly, people were engaged. Team members were engaged. People were giving advice to other team members. People were offering to do things beyond, just the bare minimum, or what was in their job description, and doing a lot of extra stuff. And that is the point where I realized that the improvements we had made didn't actually matter. What we did see was an improvement in our developer experience. So, in general, overall, all the developers agreed that after about 3 to 4 months of doing this, everyone felt like they had a better experience as a developer at IBM and as part of our group. And after talking about it a bit and doing some research and asking some questions, what we realized is the improvements in the developer experience were not caused by the improvements in our daily stand-up. So what did improve our developer experience? Well, like I said earlier, it's just saying, developers started to engage, right? And once they started engaging and really participating as part of a team, people started to believe they could affect change. So things their voice would be heard. And then that led to us starting to work as an actual team. So digging into these a little bit, how were developers engaged? So here's an example of how we were engaged. This is an example of one of our stand-ups templates filled in for Wednesday, December 18th. And you'll notice a few things here. The cat pictures are one thing. There are a bunch of icons that are themed to the actual stickies, the subject of the stickies. We have a Q check down here, which is related to this. Up here we have is Wicked Wednesday. So one of our checks is here, a Q check, and you can't see it, but it's an animated GIF. This is a screenshot. But what happened was we set the template up. I set up the template originally, and it looked very different than the template I showed you earlier. And what happened was people started either making suggestions on how to improve things or just doing it. So for example, the cat pictures was just literally one team member one day was just like, oh, I've discovered that I can paste animated GIFs on here. So they just started pasting pictures onto it. And that became a thing which people really liked. So as a group, we decided, oh, we should definitely have like at the very least one cat picture per stand-up. So this box here, this picture's covering it, but there's actually a box here specifically for cat pictures to be placed. And that evolved, right? People started making suggestions to ways we could change the board and be more productive. People started making suggestions that were a little like fun. This Q check, which this check is usually associated with the name associated, the description for the day. So the description for the day is actually chosen by someone in the group, whoever gets to this first, basically each day, and then they paste a picture that's related to that description. All these things were both improvements, both in like the enjoyment people had, but also in productivity and making sure that we could do our jobs. That was really a big deal, and more importantly, didn't happen through anything directed, right? There's no intention of this happening. My goal was just to shorten our stand-ups, but we ended up with a situation where people really felt like started engaging, right? Started talking to each other, started working with each other beyond just, oh, I'm just gonna do the next story on our Kanban board. It's I'm gonna actually pay attention to what my coworkers are doing and actually try and help them, and vice versa. They're gonna try and help me do my job, right? And like I said, this basically led to developers realizing that they had a voice, right? And not just that they had a voice, but that people were listening. So this led to ideas being proposed outside of stand-up. New things were tried. We tried a lot of different approaches to a lot of our testing, for example. People started speaking up. We actually, as a group, realized that like we wanted to start being listened to. So we had a phrase which we started using, which is if you see something, say something. Not obviously ours, but we started using it of if we saw something wrong, either inside the group or outside the group, we would say it. Like as a group, we decided we were going to speak out and make it known that maybe there's nothing anyone wants to do about this, but we're going to make sure people know that this is a problem. And all of that led to us really working as a team. And not just a team, but a good team. And if you've ever been on a good team, either in work or in your hobby or whatever you're doing, being on a good team makes you want to work harder. Makes you want to fight for important stuff that you consider important, the team considers important, right? If my team's in trouble, I want to help them out. I want to do whatever I can to help them out, and vice versa. My team wants to help me out if I'm in trouble, right? So it's really we kind of stumbled onto this whole thing, which, like I said, it's spread out beyond just the stand-up. So basically, overall, what I learned from this whole thing and what I want to share with everyone is that, like, what I learned is how you work with people is as important as the work itself. And I think I highlighted a lot of why that's important, but also the thing which I realized throughout this is that you want to change your team's culture over changes to process, right? I tried to make a one-time change effectively of I want the stand-ups to take less time, right? But really what I really wanted to do was to convince everyone that we should all care about the stand-up time, like the amount of time we spend on stand-up every day, right? And that leads to the last thing, which is you can't force people to care about things that you care about. So the culture change we experienced, and we did experience a culture change on our team, what we experienced was completely organic. It was not something that was forced. It was not a top-down thing. It was really an accident. But it came about because people were given an opportunity to have some control over what they could do. And once they realized they could have some control over a small chunk of what they do, it started to expand and really tried, like the team tried to push the boundaries of what we could and could not control. And that's the thing. Now, having saying all this out loud, it's kind of like, I mean, personally, when I wrote this all down, I was like, well, yeah, duh, right? Like none of this stuff is shocking, revelatory stuff. The part that was really a change in thinking for me is the idea of these kind of things can come out of small changes, right? As long as it's not like forced on people, as long as it's something that is from the bottom up, and it's something which starts small, right, and highlights for people the opportunities that they can have to change the culture of their team and their organization. It can really, that was the revelation for me, and the thing I want to share with people, which is doesn't necessarily take a heavy touch. You can take a very light touch to start a process where you can see real, like, significant changes to the culture of both your team and your organization. And that is my talk.
All right, great. Thank you very much, Adon. That was a wonderful overview of how your team changed and things. For those who don't know, Aton and I used to work together. We were on the same team, but I saw a lot of the good work that his team had done over time to change their culture and to enjoy work more. So thank you very much, Aton.
One other thing I want to share. I wish I'd known there was going to be a talk on how pinball machines work. The Replay Foundation, which is the foundation that lends the pinball and arcade machines to abstractions. I volunteer heavily with them, and if anyone is interested in learning more about how pinball machines work and learning how to repair them, I run a pinball repair class that gets taught by the Replay Foundation. So if you're interested, feel free to leave some comments in the Code and Supply Slack, and I will be glad to respond with information on it.
Cool. Great, thank you very much. And our last speaker of the night will be speaking to something very near and dear to my heart, in part because it's one of my favorite things that Code and Supply does. So I will tease it a little bit through this screen, but I will otherwise let Chloe take it from here.
Hey, Colin, thanks for the nice intro. No pressure. It's only Colin, Jeanne's head of Code and Supply's favorite thing. That's great. Okay, cool. Visibility is always important. I'm a woman. I'm disabled. I have a bipolar disorder. I work in tech. We've been talking about that. I'm in Slack. Just some terms I'll be using today are central modes of tendency. So it's just average, median, and mode. So in a perfect world, they'd all be the same. So mean is like the average. You take the sum of all the responses and divide them by the total number of responses. The median is like the middle value, where to line all the responses up from smallest to greatest. That would be the one in the middle. And the mode is the most common value. So that's just the value used with most of. Mode is really good for things that can't be ordered, like favorite color. So you can see some issues that we have with data that I'll touch on when I talk about the survey, because we don't have a perfect distribution. So you can see sometimes the mean can be like really over here, but then the mode is here. Like it just, like if there's too many low values or too many high values, it makes the results look weird. So it's just something to keep in mind, also stats in general. And this is also why lots of data is important. So you can see the more responses you have, the more you're approaching that beautiful normal distribution where the mean, median, and mode are all kind of the same. So that's what we're going for. Our data, I feel like, kind of looks more like this one right now. So it is a compensation survey, so I'm going to be focusing on compensation today. So we're just going to look at some demographic breakdowns. This isn't all of them, this is just some of them. So most of the survey are men. Even after we like specifically targeted women, I would say that there's like 19 responses for women and then like 13 responses from men, which I'm not unhappy about. Of course, I'm glad to get results for the survey, but it was just one of those things where it's like, okay. So men is this like blue bar, just some gender norms here. Women is this pink bar. There's one trans woman that took it, and then I think there's about 13 non-binary people here in the purple. Most who took the survey commute, that's like the large blue bar. And then most who took the survey are not managers. So this is actually 3 categories: non-manager, manager, and then the smallest category is manager of managers. So most people's total compensation is similar to their base compensation. So this is just people, and then I've kind of started to sort by gender here. So I've got base salary up here on the left, and total compensation is on the bottom. You're going to see this style graph a few times. So this nice, beautiful straight line, this is a perfect correlation. So what this is telling me is that someone's base salary is like exactly the same as their total compensation. And we have values out here, but this is telling me is this person's base compensation is 180, but their total compensation is 400. So there's never responses over here to the left, because that would mean someone inputted values incorrectly. So we can see that most people who are in this right side of this graph are men. So let's explore that some more. The guys are definitely making more in base compensation. Again, we do have a bit of a distribution problem in that we just have fewer women taking the survey than we do men taking the survey. As far as like concentration of values goes, we can kind of see similar, like really concentrated here, really concentrated here, and then we've got like really concentrated here, and then like more concentrated down here for women. There is one woman in our survey who is making a lot of money, like a lot. I don't want to say how much in case you know her, but she's excluded from a lot of the analysis because it just isn't representative. And then you can see some of the average values for trans and non-binary, and then people who chose not to report their gender. But these sample sizes are quite small, so they're not as interesting. Okay, so we saw that men were already making more than women in base. This is their additional compensation. So additional compensation is like stock options, RSUs, bonuses, anything you're making on top of your base salary. So guys are making a lot more than women are in additional comp. So we can see, you know, there's like some, you know, evening out of like gender disparity in terms of salary and base, but lots of progress that needs to be made in terms of additional comp. And then so we've got commuters versus work from homers. Remember, most people who took the survey commuted. So just keep that in mind. Again, most people's base and total are pretty similar, but some of these commuters are making like bank and additional comp. So let's look at that stuff. No major differences in base compensation. But people who work from home are seen to make less in additional compensation. That's interesting. Like, you guys are making about the same salary on average, but for whatever reason, if you stay home, you make $20,000 less on average and additional. That's a lot of money. Yeah, I don't know why that is. That's further analysis questions. Managers make more than non-managers, as you would expect, and then there's this nice stair-step effect. I broke it up this way, like it's not layered on top of each other like in the previous class, because there's this manager of managers that's making like so much money and made the graph like really bad. So I had to split it up like this, but you can just see some average values here for each of these groups. So managers are making more in additional comp. Managers and just regular managers are making about the same in additional comp, which surprised me, but I think part of it is the sample size issue. We just don't have that many managers. Most have a career path process in place at work. There is an additional question about like if you think you could use it. That's like goes from like definitely yes, and then I think it's maybe yes, maybe no, and then definitely no. It's split that way so that we can see some granular level data, you know, like not just yes or no, but then I can also collapse it into just a binary yes, no. So that's something to look at further. You know, we definitely have these two groups, but I want to see like, does it look different versus like if people feel like they could use it. So I literally just made this before it started. So these graphs are not pretty well because these have been up for a while. If you've been in the compensation survey results channel, the gender commuters and managers, and I wanted to run some additional tests in R. I don't know if you know guys R, the coding language. It wasn't working for me, and I was like, oh, they're definitely gonna understand that this thing I try to code to make work isn't working for me. So I'll just like make some extra graphs because these are areas I wanted to explore anyway. So these are pretty easy to look at because they're just like binary. So this is career path, like yes, no, in place. So yeah, those you do. So we can see that like for those of you, that's the plus signs that have the career path process in place. It looks like you guys are making more in additional comp as compared to the people who don't have a career path process in place. And then we can just see that here. Wow, if you guys don't have a career path process in place, you guys are not making additional comp. It's like your company doesn't care about you. You don't have
That
a
is
career path
completely like astounding.
Yeah, so that's something. Oh, and then I made this one right before because this is like the first analysis I've done that we've got kind of really multiple groups. So most of the analysis I did originally was like 2 groups because that's pretty easy to take in, but this is like a couple more groups. So this is like how people got a job, and you can see it's like most of the people who took the survey, I think there were 495 responses and 60 people had a response that didn't fall into one of these boxes. So like this is pretty representative of the sample. Most people know the person who got them a job. Like a third of the people got their job from someone they know. And then we've got any job board, internal recruiter, third-party recruiter, networking event, and then code and splice specific networking event. So let's look at some base salaries. So we've already got like numbers, you know, but those internal recruiters, man, those people are making bank. I mean, there's probably some like the person who's worth it for an internal recruiter to reach out to is like probably like worth more. And that's probably why. So that's interesting. And then we've got, this is their additional comp. Ooh, those internal recruiters. So they're making more in base and they're making more in additional comp. And then they're making more in total. Man. So everyone go get hired by an internal recruiter and ignore any possible third variables that could explain this relationship. Oh, and that's the end of my graphs. But does anyone have any questions? I think I went through those a little fast. Also, the tablet looks open. If you guys have any specific questions, I could just lecture you about stats in general.
I think we've got time for maybe 1 or 2 questions. If anybody has a question. While you're thinking of your questions and typing your questions in the chat, the survey is still open. It's open through August 1st. Please head over to codeandsupply.co/survey, where you can see an introduction and then click to actually take the survey. Of course, we would be nothing without the support of the community in these few organizations: Braintree, Tech Elevator, Women in Tech Pittsburgh, and Rust Belt have been very supportive as we launch the survey effort again. This is the second time we've done the survey. The first time we did it was in 2017, when it was pretty much just me, with help from a few people at our various build nights. And this time around, we recruited a team, and they have done absolutely fantastic. So please please thank them for their work. Chloe is our main data science analyst person, and Yvette Maness is our working group administrator. So any other questions? I don't see anything else popping up in chat. Now it is a great time to actually go take the survey.
Taking the survey.
So please fire up your browser.
Yes.
And go take the survey. That concludes our
Go take the
lightning
survey.
talk.
Send it to everyone you know.
I'm sorry, Chloe, go ahead.
I'm just gonna say, take the survey. Send it to everyone you know. We're interested in all responses. Pittsburgh, international. Spam it on your LinkedIn. Like, the more, the better. Like, please bring me this normal distribution. Because especially, like, you think about, like, later analysis, like, you know, right now, I can't look at commuters who are women. I just don't have enough people to say that. But if you guys give me some more people, maybe I could do commuters who are women who are also managers. So we'll see.
Cool. All right. Well, that basically concludes our first online lightning talk night. Thank you so very much for coming. We peaked around, I think my count was around 30 people watching. So thank you. Very awesome. This is going to be on YouTube. I'll theoretically already. I think I set it to be automatically public. And then if I get around to it, I might chop up the talk into individual, chop up the stream into individual videos. We'll see if I get around to it, maybe in a month or so, whenever Hard Effects is over. Yeah, everybody who knows how conference organization goes knows what life is like 1 month before a conference. I would be remiss to not put this up again so that you can see and go check it out, hardfacts.codeandsupply.co. We've got some really great speakers out there. Absolutely stoked to have this conference again. We last did it in 2018, and some of my favorite conference memories come from those 2 days with a small crowd. So we're going to hopefully duplicate that feeling online during the pandemic, and we'll see how it goes.
And always therapy dogs, which will probably be more like home animals.
Yes.
But a very important part of Code and Supply events.
Yes, indeed. We would be remiss to not have some kind of canine presence. We're planning on doing what we call a yappy hour, where people will be able to pop on a conference and show off their pets. It'll be a good time. And my last final parting words here. Please go take the survey. codeandsupply.co/survey. Your information helps others make better decisions about their career. Your information can materially change somebody else's career. So with that, go forth and do good. Thank you all.